Okay, so let's continue with our sixth video. Now that the customer subscription and support data sets have been cleared and cleaned, we move to the next stage. That's feature engineering and data analysis. So in this stage, we'll perform two important activities. First, we'll create new analytical features such as customer churn flag and complaint count. Second, we'll integrate the subscription, customer, and support datasets into one final customer level dataset. So while merging these datasets, we'll also validate the row counts carefully because an incorrect merge can create duplicate customer records and distort the entire analysis. So first, what I do is I do the head three. I check out everything like the churn score, CLTV, customer lifetime value, cancellation date. But then I see that, I need something like a churn flag because because before creating any new feature, I first preview the subscription data set, right? So so I'm specifically reviewing the cancellation date column because this column tells me when a customer has canceled the subscription, right? So when an actual date is available, it means the customer has cancelled. When the value is displayed as NAT, it means no cancellation date is available. So NAT stands for not a time and represents a missing date time value. So you may think now we have to create a churn flag. So why create a churn flag? Now the cancellation date contains useful information. But you see, dates are not convenient for directly calculating churn rates, grouping customers, or creating visualizations. So therefore, I convert the cancellation information into a simple binary feature called churn flag. So the business rule is 1 means the customer has churned and 0 means the customer is still active. So this makes the churn status much more easier to analyze. Okay. Now let's create the customer churn flag. Now for creating the customer churn flag, first we will test the classification logic using NumPy's where function. Okay. So we use np, that is numpy dot where, in the bracket, that's the parenthesis, this bracket. We put the subscription. In the list, we put the cancellation date dot notna brackets. So what is notna? This dot notna function is checks each row and asks, does this customer have a valid cancellation date? So if the cancellation date exists, the condition returns true, which is 1. If the cancellation date is missing and displayed as NAT, it returns false, which is 0, right? So that's how we get the values according to a cancellation dates. Okay. Now, you see, 1 is returned when the condition is true. Remember that. 1 is returned when the condition is like when the customer has really churned, like really cancelled the subscription. And 0 is written when the customer is still active. So you can see it here. Perfect. Let's create the churn flag. Now this is the query. So in this query, as you can see, this DF DB subscription, which is the subscription one, and the bracket list churn flag, the brackets just list. So this select or creates a column called churn flag in the subscription data frame, right? This selects or creates a column called churn flag in the subscription data frame. Now the equal sign assigns the output from NP, that is numpy dot where function, and the subscription cancellation date that note dot notna 1 comma 0 and bracket parenthesis. So you see the same condition is applied if the valid cancellation date exists. The customer receives 1, otherwise the customer receives 0. So this process is called feature engineering because we are creating a new analytical variable from an existing column, right? Now, you see, we have done the same. We have just taken this and we have just added the subscription churn flag, which actually creates a column of the churn flag, and then we have added this function here. Okay, remember that. Then we verify the updated subscription data set, and after creating the column, and you see the displayed records again. Now you can see the churn flag here. So customers with a cancellation date should have a churn flag of 1, while customers with NAT should have a churn flag of 0. So this validation step is important because every engineering feature should be checked before it is is used for analysis. Okay. So let's move on to integrating customer subscription and support data. Now, you see, this is like an introduction to data integration. The analysis uses information from 3 data frames. That's subscription, like the df-db-subscription contains the subscription plan, subscription contract, plan, and churn information. The customer, df-db.customer is customer demographic information, and df-db.support is complaint escalation and customer satisfaction information. But the common key across all data sets is the customer ID, right? So our objective is to create one final analytical data sets containing one row per subscribed customer, right? So let's validate the subscription and customer merge. So we use this query that's df-db subscription.merge, and in the parenthesis we use df-db customer on customer ID how left. So we are doing the left join here, okay? So we have joined it and we have joined the customer and subscription table. So you see, this left join keeps every customer from subscription datasets and add matching information from the customer dataset. This is important because subscription dataset represents our base population. We do not want to lose subscribed customers simply because some information is missing on another table, right? So this is how the left join works. So this is a subscription data set till here, and then after the customer is like customer name, country, state, gender, date of birth. Its left join is added here. Okay. So yeah, I think it's done very well. So in this query explanation, you can see a debrief is the left data frame dot merge combines another data frame. On is equal to customer ID specifies a common joining key. How is equal to left keeps all the subscription record while bringing matching customer information. Let's go to step 3. It's to merge all three data sets. Okay. So I combine all three data sets and store the result in the new data frame, that's DF. So I've done the same thing which I've done above for the left join on customer ID. And then again, I've merged again with the support on customer ID and same left join. So again, a left join is used so that all customers from subscription dataset remain in the final result. At this stage, the merge appears technically successful. However, a successful query does not automatically mean the result is correct. Therefore, the next step is to validate its shape. So we do that. We validate the merge data sheet shape. So the merge dataset shape shows that we have uh, so we do the query df.shape and we get 23 rows and 20 columns. Okay, so basically on the left side it's rows and 20 on the right side it's column. So however, this results is suspicious because the subscription dataset is expected to contain only 21 customer records, right? And how we do that, how we know that? Now, when we just type dfdb subscription.shape, we know that it only has 21 customer records, right? And 12 columns. So now extra two columns are somewhere. We have to find that. So we validate the customer key uniqueness. Now, you see, the number of columns here is expected to increase because customer and support attributes are being added, right? Because you see, subscription dataset is our base customer level dataset, and the final merge result should ideally also contain 21 rows. So that's why, however, you see the row count should not increase unless the business requirement intentionally allows multiple users per customer. Therefore, we now investigate which source dataset is creating additional rows. Okay. So here, as you can see, DFDB subscription customer subscription, then customer ID in the list dot n unique. We use this function n unique. This returns the number of distinct customer IDs. This basically selects the customer ID column, and this returns the number of distinct customer IDs. Now you see the result is 21. This confirms that the subscription dataset has 21 unique customers. Now the customer dataset, as you can see, if we had done the same thing for customer dataset, and we see that it also has 21 unique customers. Therefore, the customer dataset is not creating extra rows. Then we move on to support dataset in the customer ID. Now the result here is 7. This means the support dataset contained records of 7 unique customers. However, the unique count alone does not tell us the total number of support records. Therefore, I compare it with the size of the column. And as you can see, comparing unique customer count with total support records, we write the query for size, and I get 9. You see, unique customers is 7, but total support records is equal to 9. So this confirms that support dataset contains repeated customer IDs. Now, you see, let's inspect the customer records and see exactly from where those two records are added. Okay. in the support data set. Now you see here in 0 and 1, the customer ID is same and escalations are there and CSAT score is there, and the if you see the complaint date is almost the same. And if you also see here in 7 and 8, here also the customer IDs are same, but the date is different. And escalation is yes or no, and CSAT score is yep, given. So as you see this, since these outputs are appearing twice, these records are not necessarily incorrect duplicates, right? They can represent multiple complaint interactions from the same customers. So for example, the escalation status and the customer satisfaction score may be different across the records. The actual problem is difference in data granularity. So a subscription data set contains one row per customer. The support data set contains one row per complaint interaction. Therefore, this creates as a one-to-many relationship where one subscription record matches two support records. So Panda repeats the subscription record twice in the merge result. To avoid losing the complaint history, we first create a complaint count feature here. So let's create a complaint count feature. So this query calculates how many support records belong to each customer. Okay. I'm sorry for the noise. It's like, yeah, we'll continue. So this is a query for dfdb support dot group by. So this query calculates how many support records belong to each customer. That is dfdb support. It actually identifies the support data frame. Then the group by dot group by, it groups the support records by customer ID, right? It groups the support records. It groups the support records by customer ID. Now, every record belonging to the same customer is placed in the same logical group, that is a customer ID, right? Now, dot transform count actually selects the customer ID from those groups. So it selects the customer ID from those groups, right? So I hope you understand. Like, if I could explain again, this whole query actually calculates how many support records belong to each customer. Okay. So DFDB support, it identifies as a support data frame, right? That dot group by and customer ID, bracket customer ID, it groups the support records by customer ID. So every record belonging to a same customer is placed in the same logical group. Now, this customer ID actually selects the customer ID from those groups, right? And dot transform count counts the number of records inside every customer group. So the key reason for using transform instead of a normal count aggregation is that transform returns a result with the same number of rows as the original support dataset. Therefore, if a customer appears twice, both records receive the value 2. If a customer appears once, then that record receives the value 1. So let's create a complaint count to the support dataset. So this is the query, which is the dfdb support, then bracket, this is actually a list bracket, complaint count is equal to then dfdb support dot group by customer id dot transform. We have just copied this one in here, inside here. So after testing this logic, I stored result in the new column. Now this is the new column which I've created, and this result is what I've stored in this new column. Okay. So this column actually is created, that's called complaint count. Okay. This assigns the calculated equal sign assigns the calculated complaint frequency to this column. And this grouping logic then counts how many support records belong to each customer. So this feature is important because we are about to reduce the support table to one row per customer. So without complaint count, we would lose the information that some customer raised multiple complaints. Now we retain one last support record while still preserving this total complaint frequency. Moving on, let's reduce this support dataset to one record per customer. So this query selects now this is like DFDB support uh, sort values. So the next objective is to reduce the support dataset to one record per customer. Okay. However, we do not want to retain a random record. We want to keep the most recent complaint. So the first part is we write dfdb support dot sort values bracket complaint date. Now this sorts the support dataset using the complaint date column. So by default, pandas sort the dates in ascending order, meaning the oldest complaint date appears first and the latest complaint date appears last. The next function is drop duplicates. This removes the repeated records according to the selected key. What this does is removes the repeated records which are there. So extra records which are there according to selected key, and then there is like subset is equal to customer ID. It tells Panda to identify duplicates based only on customer ID column. So subset actually tells Panda to identify the duplicates based only on customer ID column. And therefore, customers appearing more than once are treated as duplicates for this transformation. Then keep is equal to last instructs Panda to retain the last occurrence of every customer. Because the records were sorted by complaint date, the last occurrence represents the latest complaint record. The output now contains one row per support customer while preserving the complaint count. Let's go to the 12th part, 12th step. So we are saving the deduplicated support data set here. The query goes as follows: dfdb.support is equal to dfdb support.sort values complaint date dot draw duplicates subset customer ID and keep is equal to last. So this is what we have just copied inside this new like support group which we have displayed. So this query saves the result back into dfdb-support. The original support data frame is therefore replaced with cleaned customer level version. So the previous query only displayed the transformed output, okay? But this actually stores the saves the result back into dfdb.support. So after this transformation, each support customer appears once. The latest complaint record is retained. The total number of complaint remains available in the complaint count, and the dataset can now be safely merged without multiplying rows. So moving on to step 13, let's confirm one support record per customer. So again, we check the size and we get it 7, which is So before, the support table had like 9 records and 7 unique customers. After retaining one latest record per customer, it now has 7 total records. This confirms that the support dataset has been converted from complaint level granularity to customer level granularity. Then we move on to creating the final integrated customer dataset, which is we merge the subscription table with a customer table and support table using left join. So because the support table now no longer contains repeated customer IDs, the merge should now preserve the original customer level row count. Now the customers without support records are still retained because we are using left joins. So their support related fields may contain NAN or NAT, which simply means no matching support information was found. Now let's validate the final integrated dataset. So you see df.shape. The final shape is 21, 21. This means the integrated dataset contains 21 rows and 21 columns. The row count now matches the original subscription dataset. So the number of columns which has increased because we added customer details, support information, the churn flag, and the complaint count features. So this confirms that the integration has preserved one row per subscribed customer. So this is the final merge integration validation. So finally, I perform a complete merge integrity validation. Now the first line, as you can see, is print subscription rows dfdb subscription dot shape. So you see this dfdb subscription shape returns a row and the column count. The index 0 here selects the only number of rows. This prints the number of subscription records, which is 21. Second line is final merge rows df.shape index 0. So this prints the total number of rows in the final integrated dataset. The result is also 21. Now the third line is to print unique customers in final dataset df list customer id dot n unique. This selects the customer ID column and calculates the number of distinct customers. Result is 21. Then we move to print customer ID is unique, df customer ID is unique. So this is a unique property check where every value in the customer ID column appears only once. So the output is true. The final validation is stronger than checking only the shape. Two datasets can have the same row count while still containing duplicate and missing customers. So by validating the row count, the unique customer count, and customer key uniqueness together, we confirm that the final dataset has been integrated correctly. So to summarize the section, we first created a churn flag. Okay, what we did first is created a churn flag. It's the churn flag. Okay, here, right here. So we then merge the subscription, customer, and support datasets right here. So during validation, we inferred that initial merge created 23 rows instead of 21 because the support dataset contains multiple complaint records for certain customers. So here is the thing. With the shape part, we got to know that there are 23 rows instead of 21 rows. And that's how we then So rather than simply deleting these records, we preserve the analytical value by creating a complaint count feature. So we preserve the analytical value by creating a complaint count feature here. Okay, this is the complaint count feature. So we then sorted the complaints by date, retained the latest support record for every customers, and merged the data sets again. So we have like sorted this by dates, as you can see here, sort values, and yeah, we have retained the latest support record for every customer and merged the data set again. And finally, we have confirmed that the integrated data set contains 21 rows, 21 unique customers, and no duplicate customer IDs. This step, this step is critical because accurate analysis depends not only on writing a successful merge query, but also validating that the merge preserves the intended level of data granularity. So we'll continue with uh, the data analysis part in the next video. Till then, thank you so much for watching. I hope you learned something from it.